All right, guys. Looks like I'm going to get started. It's 5:01 now. All right, so my talk's going to be about IoT, basically securing it, how we can, a little bit of downfalls. I'll start with some basics. My name is Aaron. I'm a pen tester. I'm also a leader for OWASP, Cloud Security Alliance, in HTCIA in the Los Angeles area. Amongst other things, we put on conferences like AppSec California, all the OWASP chapters kind of get together in Santa Monica, have a conference. It's pretty awesome. If you guys haven't checked it out, you guys definitely should. There's my Twitter handle if you guys want to catch me, my research. It's usually my research. I don't put anything personal out there, to be honest with you. So I'm going to go through just about how these devices are created, where they're coming from, what type of companies are getting involved, the supply chain process, manufacturing, the issues and kind of regulations part, and then how we can maybe move forward and start fixing these things. So just general definition: IoT, network connected object, in and out from external network, internal. You guys know the whole cars. You have your routers, your cameras, everything, the whole nine. You'll have this. Your health, you have your Fitbit, you have your watches like Android Wear, like I have myself. Everything that's network connected can be defined as an Internet of Things device. So what it takes, it usually starts with some sort of hardware, right? I mean, same thing with this watch. You have a board, usually like a PCB board or some sort of like EEPROM chip that you then build your software stack on. And with those, you have some sort of platform. You have like HomeKit, OpenWRT. You can use Linux-based, RTOS-based, which is not based on Linux. You can use AllJoyn, just basically frameworks that can build your IoT application and device kind of more rapidly and more uniformly at that. And you have this thing called the cloud. Anything that has, connects to the cloud to come back into your internal network to make the commands from usually your mobile device or a web application, whatever it is. So you have platforms like, it's called everything. So you have these, how Amazon has these little fresh things. You push a button, kind of orders it for you. Crockpot, same thing. They just have basically an SDK API that you can connect to as a developer. From there, you just have your hardware, send the commands, usually a REST API. Turns on and off. There's kind of some basic functions, motion detection, whatever it is that your module on the device is capable of doing. You can then create, schedules, automate things. That's kind of the idea of IoT, make your life kind of easier. And we'll talk, why it can also make your life more complicated. And there's, the protocols that kind of bind everything together. Wi-Fi, Zigbee, Bluetooth low energy, GSM, RFID, the whole nine, Lutron. Some proprietary, some you may never heard of. Some have security built in. Some have encryption built in. Not to say that the encryption is suffice. There's encryption keys out in the wild that you can just, Google. For example, Zigbee. Zigbee had their link master key leaked earlier this year. So anybody can create a linked device, basically a light bulb. So that's awesome. So this is a great little infographic, but it kind of goes from the ground up of physical up to kind of GSM satellite area with NFC. You have kind of close interaction, Bluetooth, and you have Wi-Fi. Kind of gets further, and Zigbee's a little bit further. Same thing with Z-Wave and things like that. So you have PAN, local area network, WAN, kind of how all these devices talk. A bunch of different protocols. Bunch of different specs, not much of a uniform manner to create these devices. It's kind of whatever works, it works. And there's a lot of startups, right? IoT is like the hot thing. Everybody wants to create this new hot device, make your life easier, whatever it is. Who has time to bind all these protocols together to talk to one another? And with that, you have something called a hub. You may or may not heard of the Wink Hub. You have Insteon Hub. You have Samsung's SmartThings Hub. And what these do is basically bridge all those protocols together so you can manage your devices from one application. Makes your life kind of simpler, but then again, opens your attack surface even more. You have not only the native app, but the hub app that you'd have to worry about security-wise. And then if you're plugging in as the manufacturer, you have to worry about the SDK you're plugging into. So just keep that in mind as I go along all these kind of different building blocks as it takes to create this one little device that may be, this book that is connected to the internet. I don't know, it tells me what page I'm on. Doesn't matter. So according to Gartner, there's going to be 4.9 billion devices connected by the end of 2015. We're probably already there. It's just getting crazy. So with these hardware that I was speaking of, you have the PCB boards, actually the low layer design boards that actually have the pads, the leads. You have to have a certain expertise. Usually in a company, there's maybe 4 or 5 from a manufacturing side of things. There's different layers, silk screens, and that all comes into play from the attacker's perspective. When you're trying to take these devices apart, you're going to want to know how these devices are put together in order to take them apart and not break the devices. There's something called reflow, and what reflow basically does is loosen up the metal on the chips, and you can basically just take it off by heating it, putting it in a microwave, which is what this is showing here, this illustration. Now here's the fun stuff. It's going to get a little bit more interesting. So there's something called BSPs, board support packages, and you're probably familiar with Marval as one of the big ones when you go through. If you guys have Wi-Fi, your Wi-Fi chipset, you'll see like Marval something and a different other Wi-Fi interface. These are the guys who create the drivers that talk from the hardware to software. Hey. And you have other companies like Texas Instruments, Intel. Broadcom especially. These are kind of the big ones though, like Broadcom, Marvell, that create that relationship between the hardware itself to the software. And these are all external parties. They all have their own software development teams. They all have their own QA cycles. This is kind of like the layer one, the level one of how to, what the first software stack that gets built on these devices. You can think of it that way. From there, you have your ODM, another additional layer of software SDKs that are being plugged into this one device that you're trying to create. And the ODM is basically another third party. Usually another smaller party. Could be a company of 10, 15 people that kind of just spit out, a software stack, a user interface that another company can put their logo on. A mobile application, it could be another startup as well. They're usually kind of spin-offs. And again, just another API SDK that people plug into in order to create their own application. So it's the idea of rapid development. The faster you can go to market, the more money you're going to get profit off of. And again, these are like dime a dozen. There's many ODMs in China, kind of in the Middle East area as well. And in the manufacturing standpoint, kind of the cheapest bid wins, whether it's ODM and as well as a chip. So when you kind of question yourself, why don't these manufacturers put secure elements into these devices, these cameras, whatever it is, it mostly comes down to dollar-wise, cent-wise, basically. Wi-Fi chip could be 5, 10 cents. The secure element could be like 30, 40 cents, and at that multiplies really quick. And with the margins of these devices, right now the justification may not be there. For me, yeah, but it's my opinion. So the cloud service providers, ODMs also use these. So you can have a whole, like the everything I showed about earlier, the everything platform. They are the ODM and the cloud service provider. So they also host their own cloud to where your data is housed and these calls are being made to. So you all have the big ones, the Amazons, the Googles. They have their security teams. They lock down their stuff, but have you guys heard of ThingsWorks? Probably not. Do they have their own security team? I couldn't find it on LinkedIn. I don't know. I was trying to dox and I couldn't find much. But again, another layer of SDKs that need to be provided in order to create this IoT device. So kind of data going everywhere, kind of many different software development teams involved, again, just to create this device. Then you have, your OEM, the person who puts their logos on. The resale and support and all warranty, any type of security issues are usually reported to these guys. These guys kind of take the PR hit more than anything, but the ODMs are the ones who they're going to have to report to fix it. So you have ODMs. So when I take a step back and talk about ODMs, I want to talk about drivers, for example, what it takes to have SMB or media sharing, a Twonky media sharing. This is all another third-party external development team that creates this. So not only do you have the ODM, but you also have these drivers as well that are also farmed out, another company that's touching this product. So to actually make that product secure with maybe 10 teams touching one hardware device is going to be an issue. So here's the general IoT supply chain process. You have your BSP, the guys who create the drivers. You have your ODMs who build on top of those drivers. And then you want to create some sort of cloud infrastructure that you can talk to and from the device to the cloud and make those kind of commands. And then you have the OEM who kind of puts it out to market, supports it, warranty. And again, all these different teams, you probably have 5 teams, whatever, waterfall, scrum, whatever it is. They're all doing their own process, procedures. Unit test, who knows if they're even QAing. So, and then out to market's key. That's that little world there. So keep in mind, everything comes from all around the world. So these ODMs, this hardware, the BSPs, everything else, they are everywhere. They're in, I heard someone ask me earlier, can we just bring everything in-house and that solve the problem? It's like, no, because the lowest bidder wins typically, and that's just the way it works in this kind of market. So, when you have everybody touching their hands, you have the manufacturing, you have people writing the code, the developers and firmware, the ODMs, the drivers for SMB, FTP, things like that. Again, all around the world from everywhere, all different types of styles, languages. They're coding in C, C++, mostly C, all in, usually in the embedded world. So in these startups, for the most part, you have very few established IoT companies. And the established ones are the bigger companies that bought out smaller companies. So likely it's still a startup within a big company. So the kind of core functions are usually sales, project managers, program managers, and the general engineers, the guys working around the clock to make this product go to market. Their job duties: get the business, outreach, create some relationships. PMs, you have to prioritize, get these products made. Specific engineering teams, and the engineers write the code day and night, split up features, UI, UX. You have Android, you have iOS, you have many different aspects of coding and coding styles and coding languages just for these devices. So, and I say that because who's looking at security, right? Who has the dollar amount? Who has the expertise? These guys are all startups. These guys, not to say startups aren't security conscious, but it becomes a question of should we invest now or should we invest later? Or do we even want to worry about it now? We want to just get money? Is the typical response you get from the startups. So usually you'll see fails. If I don't know how many of you guys are researchers, IoT researcher, any type of researcher, mobile. If you've ever looked at some of these IoT devices, mobile app, web app, things like that, it's insane. I'm kind of going to go through some of them. So here's the attack surface. I'll start from the low level, which is the hardware. You have things like UART, JTAG, the EEPROM chip, SPI, SOIC, the I2C. Buses, and you also have the tools to kind of manipulate these. You have Zippiter Shikra, Bus Pirate, JTagulator, Flash ROM, and other, just use general EE tools, as in like, electronic engineer tools, basically, to, spectrum analyze and things like that for, to short out to get a U-boot shell, for example. And ChipQuick to take these chips apart. And that's right there. That's a Linksys router, by the way. Then you have the embedded side of things, and you have like a Linux kernel running on these devices. For the most part, they are. Not all of them are running on Linux. Like I said, RTOS is another operating system that these devices run off of. So you have the regular, tool chains of embedded software. Again, back to UART, but layer 7 actually with application layer is what I'm talking about, the transport between the devices to the cloud and back down to the device. So meaning your house or not from your house. You could be remote, out driving your car, sending a command to your house, and your house sending a command back to the, the cloud, and the cloud back to your device, just to make something work. There's a lot going on in between that, and to make that secure, you have, Bluetooth and EEPROM, and, those are the most common, but the less common would be like, they're all kind of common really, but the kernel is really what's key. It's been a kind of an uprise in the Linux kernel vulnerabilities. I looked up last year, there's 115 CVEs, and about half of them are exploitable. So just think about that, all these devices being deployed with old kernels, usually 2.6, they're really, really old, 2.4, 2.3, really, really old, ancient. And to them, it's not a problem for manufacturers to create these with old kernels. It just matters if it works to them, for the most part. And you have, as far as the attack surface is concerned, you have wireless. You have Zigbee, and you have tools like Killer Bee. There's actually another tool that released yesterday for Zigbee research. I retweeted on Twitter, but I totally forgot what the name is. Soon, Zipper is going to be releasing RFCAT specifically for Zigbee, so 802.4, 802.11.4 spectrum analyzing to listen and receive, and transmit. So receive and transmit. You have Z-Wave. You have just general 802.11, meaning Wi-Fi, Bluetooth LE, proprietary bands as well that you can sniff with something like TIC 1111 is what it is. So basically that's what, I don't know if you guys heard of Sammy Comcar, but that's the kind of the little device he uses on the little girl device. It's like this little pink device that he got off of Toys R Us, and it had the same chip in there. And that's IME, correct, yes. So that's pretty awesome. And you can also just buy the chip by itself. It's not too expensive either. But just think about how, these devices, they have so much to worry about, but just, it's just one device. So that's Bluetooth LE. If you guys have a Ubertooth, those are pretty awesome. You have Android app security with WebView. You have privacy issues, client-side injections, cross-site scripting, SQL injections, the same thing as web. Specific permission issues, asking too much permissions. I'll get through a couple slides later demonstrating that with one app specifically. You have specific activities, broadcast receivers, services that are only on Android that are not specific to anything else, like iOS. iOS does not have those type of functions. So you have like filters, intent filters are what they call it, to secure those in a sense, not totally secure, but again, just Android security as a whole is a huge attack surface, and you can compromise one whole device based off of one slip up from the developing standpoint. You have memory security, so it's the same thing. You have embedded, and with embedded you have buffer overflows and things like that. Phones are still embedded devices, still very relevant. It's up to the developer to set up their IDEs according to, or in order to prevent from memory issues. There's a few switches in Android and iOS, which I'll get to next. And secure storage. You'll see a lot of credentials being stored on the SD card. You'll see them on SQLite databases in your SD card. You'll kind of just see them in the temp directory. That's from my experience. And also to think about transport security. So SSL, half these people do not validate their SSL certificates. I'm not even talking about pinning. I'm talking about validating. I could man in the middle everything. Actually, I haven't even seen one application yet to pin correctly, I should say. So pinning meaning you're actually referencing the either the domain and the certificate hash, and only pinning to that certificate. You can do it a few ways, or you could do public key pinning, which is something else. You get a SHA-512 hash. Then there's iPhone, again, another just attack surface, another way you can compromise this IoT device. Same thing with WebView. A lot of people, they're hybrid applications, so it's not only specific to iOS, but it also has a web app, basically. It uses the web app to perform its functions. And again, you have data protection as well, specific API to iOS. You have the cloud API security that it's talking to. And the SDK, again, memory security, and this is all in Xcode as well. Just three checkboxes that puts like a Pi memory canary in there. That way it can't be a buffer overflow, their application. Same thing with injection attacks, transport security, SSL pinning. A lot of what I see a lot of is kind of the boilerplate SSL code. It's just copy, pasted, allow all certificates, and call it a day. So when you think about these attacks from an IoT standpoint, they're more targeted, they're more close to home, they're more about your home. It could be your light, your plug, your camera, it could be anything, your crock pot, start a fire, whatever it is, but all this information is being transmitted in the clear. Anybody can see that information. You could be sending commands through a coffee shop, or here you could be ending up in the wall of sheep from DEF CON and you're just sending commands trying to turn off your light or something. SSL is not being pinned. They wouldn't be able to put that stuff up there if the application was pinned. Put it that way. That kills like more than half the attack surface. So it's kind of huge in the privacy standpoint. Let's see. So logging. Oh yeah, logging with iOS is funny. And the same thing with Android. You have Logcat. You just Logcat, and you can see the debug code that the developer actually intended to spit out to the console. So you'll see passwords, usernames, API keys. You'll see things like, let's see. We'll just stop there. There's a lot more than that though. But iPhone app security for IoT. You also have a HomeKit, which actually makes use of a secure element in the iOS device. So if you want to store some secrets, it's more targeted. The manufacturer could choose to do that with the iPhone devices. Android might be out of luck. You could use something like Samsung Knox for a secure element. But just, again, another way to get into these devices. Web applications, access controls and databases, web servers. Again, there is a whole infrastructure behind what these applications are talking to. It's not just the mobile device, what you see. It's actually hitting an API endpoint, a REST endpoint, and then from there, that's just the beginning. It goes from there to the app server, to the database server, and all the way back through. And who knows, how secure that is between the two. If they use an ORM, how that data is transformed between your device, between your network, and all the way back. All the languages, third-party frameworks, jQuery has a ton of vulnerabilities, DOM cross-site scripting, things like that. Just JavaScript in general, and daemons, just listening services that can compromise everything that this device is providing benefit for you. Turning your lights on and off, your camera, humidity, whatever it is, it can actually hurt you more than benefit you in the long term. And again, it's a lot of work. It's a lot of work. I'm just kind of describing all the attack surfaces, what it takes to kind of put these devices together. And this is kind of like the last one here. You have these desktop applications. You have a CD, whatever it is, to set up your camera. And a lot of times, these CDs aren't locked down to the best that they could be. Windows, OS X. I saw a talk yesterday and from one of the Synat guys, and he was actually describing how when you try to install a new router, it gives you full rewrite access permissions to the OS X box, and now you have full access as for malware. You can just do whatever you want because all these typically the way these configuration files are stored are in clear text. It's just referenced in like a nested file. Whenever you set up your router, it just kind of spits it out there, the username and password. So think about persistence, malware, bots. It's all very possible, just another attack vector that has to be kept in mind. So that's kind of how developers are after, really have to worry about all that, or manufacturers, companies. That's kind of what I look like after reading all that. No, I think this one fits. That's more like me. Especially you guys on Saturday at 5:25. Yeah. So here's some known security downfalls I'll talk about. Sorry. Thought that was funny. It's basically a quote. All the many hands touching, again, the devices and the delivered to you. So, talk about backdoors and hardware-wise. A lot of these devices are, again, created across country. You hear things from HDL code that you can never even see, you'll never even know. BSPs can be kind of sketchy sometimes. Could be a developer who's disgruntled, whatever it is. It's hard to kind of knock down the supply chain process and manufacturing process of these devices, just because the nature in which the market is and how they've been created for years. Now IOC is just kind of having a big upheld in sales and things like that, and media, and everybody just wants to create it. But with all the different hands, again, you get things like this, which is fine. Some of them are fine. Some of them need to happen for verification purposes, like UART pins exposed, but they use simple passwords, no passwords. So serial connections on the hardware aspect of the device. They're just serial headers, basically, that you connect to. You have manufacturing debugging scripts, so you'll have services listening, send a certain header, and hey, you have a shell, hey, you have admin access now. These are things that have happened, and I'm sure you guys may or may not have heard of them. Again, so backdoors with secret user agents. Put a little present there because the developer put a little present for himself, then he can access any router, any camera, anything he wants that's facing the internet. Private keys on devices, usually try to put them in a different partition, or thinking that it's safe because it's on the hardware device themselves and no one's going to get access. People it's their device, they can do what they want, and they are going to look at the hardware, so I wouldn't rely on private data on any type of client-side device. So you have a lot of default passwords as well. A lot of people keep their devices with default passwords, set up their routers, their cameras, any type of device with their default passwords. As long as it works, and they don't have to worry about it. Set it and forget it. But that's what a lot of router malware consists of, is taking advantage of those people. A lot of them just kind of scan, and there's a few out there that kind of just go through each router manufacturer and submit based off of CSRF, the admin username, admin password. So admin, if it's D-Link, if it's TP-Link, they'll type in admin1, whatever it is, or blank password. But again, to speak about HDL code, again in backdoors that can be so stealthy you will never even know, and we probably won't know. It's probably already happening. I've heard some conversations outside that manufacturers are thinking about that. Not manufacturers, I'm sorry, BSP and chipset providers. So how can we kind of make this better, right? With talking about all the bad things, we kind of want to move forward and see how we can not get access to shell. If someone just gets hardware access, physical access, life's over. Maybe we can try to put some tamper resistance on these headers, UART headers, JTAG headers, whatever it is. I'll silk screen them, kind of try to put a couple layers for these researchers or whoever. I mean, the point is to kind of make it life harder. We want it more secure, but at the same time, we want to do the most due diligence we can to kind of keep consumers protected. Maybe some very long passwords to get access to UART or any other type of interface for default web admin or mobile admin, whatever it is, password. Doesn't matter, as long as it's long. Update kernel packages and keep it updated as you send out new products. I think that's kind of huge. Like I said, a lot of old kernels out there, and they're not getting any newer. And I don't know if you guys know, but with kernels, it's kind of a pain. They're going to want to change their whole code base based on the kernel, or be scared to change their whole code base based on new kernels. So we can also harden the operating system. It could be based off BusyBox. Like I said, services running. You guys hear like the Parrot drone. That's a few rooms down. I had Telnet open. He just got onto the network, got on Telnet, and then pressed halt, and just the drone died just because it had Telnet. Without that, I mean, all you have to do is turn off Telnet. If you're not using it, don't use it. That's how I see it. So it can be anything from Telnet, FTP, SSH, vulnerable services, just listening, and then down to just updating the software stack. Whatever it is, if there's a vulnerability, it has to be a fast and quick and easy way to update these devices. Otherwise, you're going to have ODs out there that are not going to be fixed, and people are going to be vulnerable to these zero-day attacks. And they're going to be exploited. They may not have specific statistics on this, unless you're running some sort of honeypot or honeynet or things like that. But they're definitely out there, and it's definitely real. So with that, you have like secure C functions, again, all embedded, string copy, mem copy, and things like that. And of course, verify and test your code. QA your code, get security teams involved early. We'll talk about other ways you can, without people who don't have the money to have a security team, there's other ways that you can test your devices. So here's a little image from to actually not use like strl copy. There's another from mem copy, but you guys want to take a second, like sprintf. Basically, they're not validated, so don't use them. I respect myself. That's why I use sprintf. All right. So there's also kind of a regulatory impact. They're trying to make some sort of hedgeway in this kind of aspect. So, they made a statement earlier on this year, maybe late last year, trying to implement security by design rather than grafting security as an afterthought. Build into your product services as an outset of your planning process. So again, get security involved in design and throughout the SDLC. Test before code is being deployed. Test it after it's being deployed, after it's all built. Is kind of the idea. And then privacy by design. Take as little information as possible from the consumers, these devices, whatever it is, on any type of platform, Android, iOS. And it's interesting with the categorization of IoT devices. They kind of try to put, what is IoT device and what is not, from the FTC standpoint and the EU Commission standpoint. But at this point, there's no regulations for these consumer devices, so that's kind of the biggest protection at this point. There's no like PCI or anything like that. There's no, anything being brought upon the manufacturers to implement any type of security by design or privacy by design. So of course, if it's not, required, they're not going to do it. It's just more money, more time for them, more process change, things like that. So yeah, privacy by design, security by design, yeah, we'll see how that works. Right when I open up my IFTTT app, it asks me if I want to read my call log, when it has nothing to do with reading my call log. At all. And then my SMS messages, it has nothing to do with reading my SMS messages. So what IFTTT is, it basically, it's almost like a scheduling tasker. You can set your either IoT devices, Android devices, your email, things like that, and kind of automate things is the idea. But this controls a lot of like Samsung Smart Things and your Nest devices and things like that. So to me, I think it fits in the realm of IoT. So when you see apps asking for permissions that is not necessary, it blows my mind to think that they're ever going to change their processes according to FTC unless something's actually regulated by them. You can't see that, but this is my IFT mobile app sending a bunch of analytics every 10 seconds back to their cloud. And I'll show you right now what it says, but it literally 10 seconds. I just went to the restroom, came back, and I was like, whoa, all right. This is analytics here, and this is what it is. Oh, you can't even see it. Basically, client secret, my Android version, my time zone, my device name, my API level on my Android device, my login, my user secret, just every 10 seconds. And again, this is obviously this isn't SSL pin. This is just being shot off. So if I'm in, again, a coffee shop, whatever it is, you can grab that easily. So privacy by design for a company, IoT company like that, I don't know. It doesn't seem like they take it pretty seriously. So aside from that, with the FTC statements, what they didn't kind of address is the supply chain process. Again, how these devices are created and from the beginning to end. It's kind of how I've been describing. So again, I kind of keep talking about it. Is kind of liability. These guys aren't going to change unless something changes with their responsibilities and how they push these devices to production. You can try your best to create security agreements. Not security agreements, but like master service agreements with the ODMs so they can do their own due diligence and security testing, and kind of how like partners do to get into companies like Google, Microsoft, Fox, any type of media company, to have them do a pen test on their app, on their SDK, whatever it is, source code analysis, whatever it is, and then it's vetted out, at least it's looked at. Not to say that's secure, but at least it's one step towards the right direction. Again, legal repercussions. I don't know. I keep thinking about PCI, but again, I think it's just one step that needs to be taken in order to kind of fix these problems that we're having. Community projects, you have OWASP. There's a few, IoT top 10 is actually right here. I don't know who put it here, but if anybody wants to grab it. So there's also Cloud Security Alliance. They have IoT for early adopters, how to deploy these things in production, how to do threat models, how to pen test these devices. Really good info out there for anybody to get involved. I think half the problem is the awareness to consumers. You don't want to scare them. You want to make them aware of what these devices are actually doing and how we can make them more secure. Because, again, consumer devices, consumer companies, manufacturers, if there's a breach like Target, Home Depot, they're still going to go to Home Depot and Target. So we just rather have them more aware that, hey, yeah, just to let you know, that guy right there is going to be viewing your camera tomorrow at 12. You know what I mean? I don't know, just some things to keep in mind. Not him specifically, but. So security process into SDLC, like I said, product design. From right when the product is being thought about, okay, I'm building a camera, I'm building a crock pot. What can it do? What can it do? Get security involved. Let's see what we can, vet out. Have just security in the calls. You don't have to be on every type of, put your input in everything. But if you hear something, definitely put your 2 cents in. It could be something like a certification, like Wi-Fi Alliance. Maybe a little sticker. Hey, yeah, it's certified. I don't know. Again, it's a checklist approach, but it's just one step, I guess, in the right direction that we can try to do. Same thing with Zigbee, but those are kind of like pay-to-play type of organizations. But still, like I said, some sort of certification that has the bare minimum security. Of course, they're going to shoot for bare minimum, but again, some sort of step in the right direction. And who knows if that's even realistic, and if it'll ever happen. But we'll see. Maybe in the next few years, as these devices become shooting at billions, like we're saying, 20 billion even in the next few years, from what I've saw from Gartner. So the key is defense in depth. Obviously, there's all these different attack surfaces: web, mobile, and specific Android, iOS, hardware, embedded. So do what you can to help. There's organizations, like I said, OWASP, where you kind of become more aware in the different testing methodologies. You have third parties like BugCrowd and Build It Securely, which they have researchers kind of on hold that you can exercise to look at your IoT devices from the manufacturing standpoint. And BugCrowd, if you're a manufacturer, you can have a private bounty with BugCrowd, send your devices to a few people who are interested, who know hardware, software, whatever it is, who are kind of proving themselves in the industry, to vet out your application, your device, your cloud infrastructure, whatever it is, just so it can have more eyes to be looked at. The more, the better is the idea. We just keep hitting these manufacturers in the head, keep shooting in these bugs, 0 days, whatever it is, because otherwise it's gonna get complicated, and it's getting complicated. But that's the idea for me, though. All right, that's it. Any questions, guys? Yes, sir. It's not a matter of, did you say like difficulty wise? How hard is it? It's not a matter of being hard. I think it's just about the vetting of the new code, QA test processes, and then if you want to have security tested again, if it's involved with security, it's just a process that has to be defined within a manufacturing company. So it's in an immature state right now. So how many IoT consumer companies have security teams? You know what I mean? So you're probably a handful. Most of them are big. Mm-hmm. Okay, so Apache-wise, that's more, yeah, or light HTTPD, whatever it is. It's pretty simple. There's usually already a workflow created for an established company, consumer device company. It's just a matter of them if they want to automatically click in a box. For example, you'll see those on maybe your routers or your cameras. But some manufacturers, they make it harder. They make you actually have to go to their website, download it, save it locally, and then like browse it for the file, that whole process. So it's kind of up to the manufacturer how easy they want the workflow to be, the user experience. But for the most part, for established companies, it's usually just a click of the box, check now, for more updating. There it is. Light HTTP header is no longer there. You have no services, no service versions broadcasting. So again, it's just a matter of maturity, really, on their updating process. Yes, sir? Mm-hmm. So it's hard. How can you do analytics on the number of researchers who are attacking at the hardware level, on the low level, the physical level? I mean, it's more of a specialized area. I mean, there's a lot of them here, a lot of the security researchers who actually attack at the hardware level. Sometimes you don't have to, but as far as analytics are concerned, the number of people or attackers that are doing that, there is no number. There's no way to kind of keep track of it unless you guys have you guys have an idea that can maybe work. Maybe people kind of putting a platform out and kind of like, hey, I'm one of those guys. I'm a hardware security guy. I don't know. Maybe the hardware guys, yeah, they're actually right here. It's probably them. All of them. Any other questions? Come on, one more. Sweet, yes.
What about the hub? Nowadays, a lot of hub at home are very on.
Mm-hmm.
You show the hub that every manufacturer company that makes product
Mm-hmm.
hub.
Yeah. So the security of the hub, you're saying? It's in.
It's going to be like your application. Will it run applications or just like regular routing in our homes?
No, it connects to your router. So you pair it with your router, and then from there you pair your device to your hub. And then from there you control it through your mobile app.
Yeah, but it's super just like forwarding the
For the most part, there's an SDK API that one of the hub providers, Wink, SmartThings, Insteon, they provide that the manufacturer uses to connect to them. So it's not the same exact code. It's not the same exact code, but it's just, again, broadening the attack surface, something else you have to worry about. It's not only your product now, it's their product that connects to yours, and then it's your home. You have multiple ways to control your device, and how well can they do it and how well can you do it as a manufacturer. Anything else? Any other questions? Last ones? What's that? Yeah, they're actually on Google Sites. I can even tweet it out if you guys want them. If you guys have my Twitter handle, I'll tweet it right after the talk. All right, thank you.